Here's another example of completing the square. This time we're going to look at an example that involves what appears to be an incomplete non-monic quadratic expression. So 9x squared plus 7x plus dot dot dot, and we want to find a value that completes the square on this expression. Now, we may have seen earlier that a perfect square, or an expression that is a perfect square, can be expressed in factorized form as a perfect square binomial. So we could express this sort of the equivalent sort of expression to this in factorized form really is in the form a plus b all squared. And hopefully we've seen that before. That's just a perfect square in factorized form. So we want to find the question mark. What can we add to this expression to turn it into a perfect square? Now we know that when we expand a plus b all squared, so it's just a bit of a review here. If we expand that, that's just a squared plus 2ab plus b squared. And a squared plus 2ab plus b squared is, well, we're going to basically equate it to this expression here, 9x squared plus 7x plus question mark. So we know that when we expand this perfect square, the a becomes a squared, 9x squared. In fact, do that in reverse. We take the square root of 9x squared, and in fact we get the a term immediately. Okay, so I might just write this on another line here. 9x squared plus 7x plus dot 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 is equivalent to, now the a we know from what I just spoke about earlier, that the a is in fact 3x, because we know that when we square the a, we get a squared, and that in fact corresponds to the first term of this expression. So that's all good, but we don't know what the b is. Okay, so when we expand this expression, the second term of the binomial becomes the, well, I wouldn't say the constant term, but the third term of this quadratic trinomial. So b, when you expand it, becomes b squared. Okay, so I guess what we're sort of trying to find here is we're trying to find the value of b, so that when you square it, we end up finding the third term of this expression, so that it becomes a perfect square, or can be expressed in perfect square form. Okay, so what we're going to do is we're going to now sort of reverse this, start with 3x plus b all squared, expand it, and then equate the terms of each side of this expression, okay, of this equivalent statement. Okay, so starting off from this side, so 3x plus b all squared. When we expand that, we get 9x squared plus twice the product of the terms inside the bracket. So 2 times 3x is 6x, 6x times b is 6bx plus b squared. And this is equivalent to our original expression, 9x squared plus 7x plus dot dot dot. Okay. So we know that obviously there's a b squared there. Trying to find the value of it. So the clue is in the middle term. This term here should be equivalent to this term there. Okay. So let's equate these two separately. Okay, so we've got 6bx is equal to 7x. So 9x squared is equivalent to 9x squared there, so we don't have to worry about these two. This b squared is equivalent to this b squared, so we don't have to worry about that. So the key is really in the middle term. 6bx is equal to 7x. 6b is equal to 7. Therefore, b is equal to 7 on 6. Okay, so in fact, b squared, hence so I'm running out of room there. B squared is equal to 49 on 36. Therefore, the perfect square, the completing the square, or the third term, okay, the completed square, should I say, is, go back from the beginning there, 9x squared plus 7x plus 49 on 36. And expressed in factor form, that's just 3x plus this value of b that we just found, 7 on 6, all squared. And if you like to check it, you can expand that, okay, 3x plus 7 on 6 all squared, and you should end up with this expression here. Thanks for watching, everyone.